Okay, as promised, here is part 2 of the video. And so now I'm going to go through these questions. If we look at number 11, it says the functions m and n are defined for all real numbers. In the xy plane, the graph of n is constructed by applying 3 transformations of m in this order. So first we have a horizontal dilation by a factor of 3. When you see something that is horizontal anything, it impacts your x and it does the opposite. So if it says factor of 3, I know I need a 1/3 next to my x. So C and D are out. All right, we have a horizontal translation of 5 units. So that means I need an x minus 5 because, again, horizontal things do the opposite. So now of my remaining choices, A is out, and so it has to be B. All right, and if we did continue to look, vertical translation of 4 units, well, they all had a +4 at the end. This is really just seeing if you knew how to work with your horizontal things. Okay, next question. If we look at the next question, it says we have points A, B, C, D, E, F. We want to know the points where this graph has a local minimum. Local minimum is bottoms of hills or endpoints. Bottom endpoints, I should say. So if I'm looking here, A is not a bottom point on an endpoint. B is the bottom of a hill. C is the top of a hill, so that's not a local minimum, that's a local maximum. D is the bottom of a hill, so that one's good. E is the top of a hill, so that's a local max. F is an endpoint that is at its lowest, so we'll call that a local minimum. So B, D, and F. Okay? Now remember, on your benchmark, this could ask local minimum or it could ask local maximum. So make sure you know the difference between the two. And always double check your endpoints. All right, continuing on, let's go ahead and look at number 13. Here it says, what is the domain of R? Okay? Domain is going to be everything except where the denominator is 0. So everything except where denominator equals 0. So all I have to do is just factor this x squared plus 2x minus 3. That'll be x plus 3, x minus 1. So we get -3 and 1. So I know it's not A. I know it's not B. It has to be C. It can't be D because I don't have any x minus 2 or x plus 2's in the bottom. So answer is C. So when you're doing this question on your benchmark, just make sure you take your denominator, factor it, find those values. I don't care how the numerator factors. I'm not trying to cancel anything out because even if you did have something cancel out and thus have a whole, you're still going to have that be an undefined point. So just factor the denominator and only look at the denominator for the domain. All right, next one, we got another sign chart problem. This time it says, when is our function less than or equal to 0? All right, thankfully this is already factored, so we can go ahead and just find our numbers that we need. So those are the numbers that will go on our number line. I'm going to use this space up here. Let's see, -3 goes first, and that's going to be a closed circle because of our inequality symbol. 0 is going to go here, also a closed circle, and 2, also a closed circle. Okay, this is just a polynomial. It's not a rational function. So if the inequality has an equal to, all your circles will have an equal to. But when you look at your answer choices, they already have all the brackets in there. So really, if you didn't put the closed circles, it's not going to matter. Okay, so let's go ahead and pick our test numbers. I'll do -4, -1, 1, and 3. When I look at my factors, I have a factor of x. So the factor of x is just going to be the sign of the test number you picked. So I know in this one it'll be negative, negative, positive, positive. For x plus 3, if I plug in -4, that'll be a negative factor. If I plug in -1 to that factor, that'll be a positive factor. If I plug in 1 to that factor, it'll be positive, and if I plug in 3 to that factor, it will be positive. All right, for the third factor here, notice that this factor is squared, so it really doesn't matter what number I put in there. Once I square it, that factor will always be positive, so I'm not even going to bother to plug in anything for it. I'm just going to use what I have here. All right, we're looking for intervals that are less than or equal to 0, so negative numbers. So this first interval where I have 2 negatives, that makes a positive. So we're not going to have negative infinity to negative 3. So A is out, B is out. Next we have negative times positive. That will be an overall negative. That is true. From 0 to 2, I see that we have a positive and a positive, and then from 2 on, we have another positive. So the only interval here is from negative 3 to 0. All right, let's look at number 15. On number 15, we have a table, and it says which of the following could be true. We're looking to first see if it's odd or it's even. So odd means when input changes sign, output changes. So output is opposite. Remember, odd things do the opposite. So what I'm going to do is I'm going to look for a pair of inputs that are opposites, such as this negative 5 and this positive 5, and I'm going to look at their outputs. I can see those are the same, so that makes this be even. Okay? I didn't even talk about the even, but on even it says when inputs change, the outputs stay the same. All right, so this one will be even. So now I know that, I can eliminate A and B. We want to figure out what h of negative 4 is. So I'm going to look at h of positive 4. Positive 4 gives me 7. So negative 4 should also give me 7. So D is the answer. But make sure you know both of these definitions, because this question asked about, or this question gave us an even function. You could encounter an odd function on your benchmark. So just be ready for both of those. All right, number 16. If we look here, we have a picture of a figure here, and we're transforming it in such a way that we have, this looks like we go right 2 and down 1. When you're doing this, you can, since we know that's going to be right 2, down 1, you could just take these points that are on this graph, send them right 2 and down 1, and see which one matches. Or another way you could do this is you could think of your coordinate rules. This is how I usually do it. If I know that I go right 2, I'll have my x and I'll add 2, because remember x does the opposite of what we think. And then y minus 1, because the minus 1 is a vertical movement. All right, but either way, when we are doing this one, we should end up with, let's see, so this point here was originally negative 3, 3. If I add 2 to this and I subtract 1 from this, I end up with negative 1, 2. So let's see here, negative 1, 2, this isn't it. Negative 1, 2, that one's not it. Negative 1, 2, that's looking good. Negative 1, 2, that one's out, so our answer is B. All right, number 17. This will be the last one that I do. For this one, we want to first figure out the factored form of this function. So 2x minus 4, I'll write that as 2 parentheses x minus 2. On the bottom, I'll factor that as x minus 3, x plus 2. And now it says state any vertical asymptotes. Well, I don't see any cancellations, so I have 2 vertical asymptotes, x equals 3, x equals negative 2. Horizontal asymptotes, for this one, I'm going to go back to the original form, and I'm going to compare the degrees. The degree on top is less than the degree on the bottom, so it must be y equals 0. X-intercepts, I look at numerator factors, x equals 2. And it's because of the factor of x minus 2, not because of the 2 in the front. The y-intercept, for the y-intercept, just plug in, well, if I can spell, you're just going to plug in 0 for x. So plug x equals 0 into equation. All right, so I have 2 times 0 minus 4 over 0 squared minus 0 minus 6. So that's just going to give me negative 4 over negative 6, which is 2/3. All right, for the limit, the end behavior, notice it says the hint, use the horizontal asymptote. Limit as x decreases without bound means limit as x goes to negative infinity. Our function is f of x. And because we have a horizontal asymptote, that horizontal asymptote is the value of our limit. And that is true for both ends of a rational function. So when we do increasing without bound, x is going to infinity. But in the long run, the function will still approach the horizontal asymptote. All right, my friends, that is all I've got here. Miss Majors will do the FRQ practice with you, so stay tuned for that video. Thank you for your attention, and good luck studying on your benchmarks.